Okay, so today we are going to talk about this one called recursion. Okay, recursion. So recursion, we will focus more on how recursion program been done, but more focus on the multiple choice portion, because recursion never tests you the FRQ. Okay, they never test you the FRQ question. So far, no, and I don't see that coming year they are going to test any recursive program. Okay. But you need to know about what's the basic idea of recursion and what are the aspects that in the exam you need to know about recursion. Okay, so let's look at the recursion. So first one is that you do problem solving, you study the computer science. Okay, and the algorithm, there are a lot of topics in algorithm study. Basically, they are algorithm you need to study. Okay, sorting, approximate the solution, random solution, dynamic programming, linear programming, crystallography, Fourier transform, computational geometry, whatever algorithm. So each individual one here can be a college course. Okay, college, each one of these can be a course. Linear programming, that's one course. Crystallography, that's one course. Okay, computational geometry, these can be a one course. And then other than the problem itself, you also need to know about what is the efficiency of our algorithm, okay? And also what data structure can support it. These are topics that we need to learn in learning algorithm. But today we more focus on the recursive programs, okay? Recursion, we focus on recursion. So recursion, three things you must remember. One is the base case. The other one is a recursive call. And then you need to know about step-by-step improvement. Okay, these three things you need to know about it. First one is the termination condition, base case. And then you need to know about the recursive formula, and then step-by-step improvement. So let's look at what is recursion. So first, let's look at the mathematics. You may have taken the honor pre-calc. Many of you may have already taken honor pre-calculus already. So you may have learned the sequence. So when you learn the sequence, you should know that A1 equals 1, A2 equals 2, A3 equals 3, okay, A4 equals 4, okay. So an equals n. Okay, so this one is called sequence. And the equation of this one, an equals n. This one we call it explicit formula. Okay. I'm sorry, let me rewrite it. Okay. It is called explicit formula. Okay. But if you write it this way, you have A1 equals 1, A2 equals A1 plus 1, okay, A3 equals A2 plus 1, A4 equals A3 plus 1, and then go, and then AN equals AN minus 1 plus 1, okay? So this one, we call it what? What's the name of this one? Same sequence. What's the name of this one? Okay, this question, let me find Grace Jean. Okay, Grace. What's the name of this formula?
Recursive formula.
Yeah, this is called recursive formula. So here we have a definition for what is recursive. Okay, your sequence definition based on your previous items definition. That's called recursive definition. This one, no, your AN equals N, you directly write out the explicit formula that you already write out the data. Okay, so there is no recursive code, it's called explicit formula. But both of them in math, we have such a recursive and non-recursive definition. Okay. Okay, so go back to our programming. We do have a termination condition. Okay, so let's actually write that into our program. Okay. I'm sorry, let me create a new directory, okay? So let's call recursive. Let's call recursive. Okay, so this one we call it week 7. Okay, it's week 7, chapter 8 for parent. Okay, so right here, let me create a sequence. Okay, so sequence. So a sequence in here. Okay, a sequence in here. You can use a static. Okay, integer array. Okay, a equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this one is one. This one is sequence by sample. Okay, you create a sequence by putting it into an array. That's a sample. Okay, that's called sequence by sample. Or some people say this one is called a sequence by what? This one is sequenced by Rooster. Okay, Rooster. By the members. Okay, that's one thing. Second, let's look at another one. You can do explicit formula. Okay, explicit formula. So public. Okay, integer. Okay, explicit. Okay, so let's call it AE. Okay, AE. You get an N, and then you have an explicit formula. You say return N is explicit formula. Okay. So that's one way to represent your sequence. Another one is recursive definition. So public, okay, integer AR, recursive version N, okay, given an N if N equals 0, okay, then we return 0. Okay, this one we call it base condition. Otherwise, you will do return an equals what? AR of n minus 1 plus 1, right? This one based on what we just discussed a moment ago. Your an equals an minus 1 plus 1. Okay, if you using the recursive formula. So this here is recursive formula. Okay, and here you have base condition. Okay, is that okay? So now we can have public, okay, static void name. We try to test it. Okay. Okay, here the function we need to make it as a static function. Okay, Okay, and here we have a three definition: one by array, two by function, and then all of them work in the same way. They will give you the all of the data, okay, in the same format. Is that okay? It's in the same format. Okay. So there's a different definition. One is using recursive formula. One is using array. The other one is using recursive. Okay. Now there's a question. Okay. Our demo. Okay, demo. What's the advantage of using a array, and what's the disadvantage? So pro and con for this one. A demo. What's good about this one and what's bad about this one?
For using an array.
Or using an array, yes.
I guess you can get a faster run speed.
Yeah, the number efficiency is higher, yes. What's the cons?
The con,
what's bad about it? The cons should be very apparent, right?
well, I'm not really sure about it.
You have limited space. You can only say 10. Can you say 2,000?
Oh yeah. No.
It wastes a lot of time, right? But can you do 2,000 easily here? Very easy, right?
Yeah.
Okay, so that's a con in this one. Okay, now we have these two formula. We have the recursive definition and non-recursive definition. This one for Eric Yu, okay? What's good about this non-recursive definition compared to both the other two? What's the pro and con for this one? What's good about this one and what's bad about this one?
I think a non-recursive definition is faster.
Faster to recursive, but slower than array. Okay. Okay, and then cons, best things.
I'm not sure about the cons.
Cons is that you sometimes cannot find the explicit formula. Okay, so right now, an equals n, that's very easy. Okay, this one's very easy. But how about this? If we do summation of the I square, okay, I come from 1 to n. Okay, so this is called sequence of n, right? So you have 1 square plus 2 square plus 3 square plus 4 square plus 5 square up to n square. So what's the sum of this guy? Can you find a recursive? Can you find a non-recursive explicit formula? What is the explicit formula for this guy? Hey, Eric, do you know?
Yeah, I just need a sec.
Do you know? Do you know the formula?
I don't think I know the formula.
You don't know the formula? The formula is this: n times n plus 1 times 2n plus 1 divided by 6. Okay? Some people like me remember it every day, okay? But a lot of people actually don't know. Then this one is not easy to be remembered, right? So then you need to have a recursive definition. So your Sn actually Sn of n equals Sn of n minus 1 plus n squared. Is that right?
Yeah.
Yeah, so that's the formula. Okay, that's the formula you will have. So you will easily find the recursive version, but this the so-called non-recursive version very difficult to find. Okay, here I just tell you how this can come out. Okay, but there are some systematic way you can actually calculate summation of I squared, summation of I cubed. Okay, there are certain way you can do that. Okay, this will be introduced in the course of discrete math. Okay, so here I don't talk about it. Okay, but there are certain way you can do that. Okay, but here, okay, we compare the using the array and using the function to represent the sequence. Okay, and we are in AP concept review. So let me show you the basics idea of why we want to do recursion. Okay, why we want to do it. Now, this one finished. Let's actually look at another way to look at the recursion. Okay, so number one, we need a recursion because we have some formula we may want to create. Okay, some data we may want to get. Second one is the style. The style of the recursion. So what are the style of the recursion you may have? Okay, so that's actually write a program. Okay, write a program. Let's assume that we want to write a program that actually do countdown. Do countdown. So here let's do actually public. Okay, static. Okay, void. Okay, and countdown. Linear. Okay, linear version for do countdown. Give me the integer n. Okay, I'm going to count down. So I'm going to count this one down. So here, while okay n greater than 0. Okay, I'm going to do this one. I say system.out.print my n plus exclamation mark. Okay, and then when I count down to 0, I say system.out.print line. I say press off. So this one is like you go to the NASA center, okay, and then they try to shoot a rocket to the moon, something like that, okay, and then you do need to do countdown. So this countdown right now, this version is the so-called iteration way, iterative program. Okay. This one is an iterative program. You do countdown, you count it down one by one. So we do this one. We do countdown linearly from 10. Okay, we do countdown linearly from 10. Okay, so here we do system.out.print clean the screen, /f. Okay, countdown linearly. So what's wrong with it? Okay, I misspelled it. Okay, we have the countdown linearly. I actually print a new line. Okay, between the new line marks. Let me actually run this one and run. So you do countdown. Wait, I forget one thing. I forget to count down. So my n need to decrease. Okay, and my n need to decrease. So this one's countdown version. So here we do see the result. That is 10, 9, okay, whatever press up. Okay, so we want countdown. So this one countdown again, it actually is a linear version. So you actually do 10 come in, okay, and then print 10, drop to 9, drop to 8, drop to 7, okay, keep doing the countdown. This one is non-recursive version. Okay, now let's write this one in recursive version. Okay, so let's do this one. We have a recursive version. So public, okay, static, okay, void, and then countdown, and then let's get the integer n, okay, coming down here. Okay, so here if actually n equals 0, okay, and then this one I do print. Okay, I do print. Okay, I do print. After I print, I do need to type return. Okay, otherwise here I actually do count down of n-1. Okay, and I will print out the n and then count down. Okay, so I do this. Okay, and here count down. Okay. Now the question is, okay, so why here I need to have a return? This one for Henry, okay? Henry, I think you're Henry Ian, right? Henry, why here return is needed?
I'm not too sure.
You're not too sure?
Is it because wait? Oh wait, no. If n equals 0, you just continue. So after you print out blast off, it's just gonna continue. It's gonna print 0.
If you don't have return, right?
Yeah.
You print 0 and then what happened?
And then it goes to -1, and then it just continues printing negative
okay.
numbers.
So this one actually is breaking the function, okay? So this one actually is a base condition, okay? The base condition, you must terminate your program, no more call, okay? You cannot continue to call. So this one, with a return, here you will break the condition, okay? So here, if I copy this one, okay, I pass it over here, okay? I copy this one and I put it over here. Same thing for Henry, is that okay?
Yeah.
That's okay, but
No. Wait. What? Wait. Yeah. That because like when you call countdown, you don't go to that return. So like that return's like useless.
No, that return that actually is useful, not useless.
Wait, what?
Okay, let's see. Okay, let's see. It's useful but redundant. Okay, I'll say redundant. So you count down 10, you go to count down 11, go down, count down 0. Count down 0, you brush off and you return, right? You return to countdown 1. So you finish the countdown 0, countdown 1 will finish the countdown 0, and you'll return.
Okay.
So this one still be wrong. It's not something that you don't wrong, okay? You still were wrong.
Yeah.
But you don't write it. If you don't write it, okay, that's assume that you don't write it. It still return. So it's something like you write it, you return. You don't write it, you still return. So it's redundant but legal. Okay, this one is redundant but legal. Okay. So what I want to say right here is that you put a return for void function, it means breaking. We have 3 break level. One is to continue. Continue will break iteration. Okay. And if we have a break will break a loop. Okay, here we have return. Return will break a function. Okay, and then there's a system dot exit 0 that will break the whole program. Program will terminate if you run this one called system.exit 0. Is that okay? These are 4 break label you need to remember in Java language. Okay. Sometimes you need it, but return you break the function. Okay. But this one is redundant. You write it or you don't write it, actually doesn't matter. Okay. This one doesn't matter. I can comment out doesn't matter. So this one countdown. This one is necessary. So that's wrong. Okay. This one is actually necessary. If you don't terminate on your base condition, you are going to be in trouble. Okay. So here, this one. Okay. This one. Okay. So let me actually, for this one, let me actually put 2 exclamation mark there. So you know that it is from this countdown version here. Okay. So that one, okay. Okay. 2, okay. But here, if I take out the return, okay, that's assume that I somehow forget it and cannot return. And this one, we are in trouble. We are in trouble because the base condition never terminate and you go into the stack overflow. Okay, it become negative. Keep doing that and it become negative. and never stop. Okay, and never stop. You cause many step overflow problem. Okay, and that's actually move back. Okay, let's move back, move back, move back, move back, move back to 0. So here you see. Okay, sorry, let me actually make it smaller. Okay, so you scroll up, you do see it actually going to from one press up, after press up, it continue to decrease because you do not terminate your base condition. You do not. So after you run the 0, you print the press up, everything happy, yes, you press up, but you continue to count down here. You pass the -1 to the countdown. You keep going. Okay. Any question up to here? No question? Okay, but can we write a recursive program without such a problem and just use if? Yes, you can do that. Okay. So here let's write another one called public, okay, static, okay. Void countdown yes version, okay. The countdown yes version, let's do this, okay. So here I don't say n equals 0, I say this one, I say if actually n not equals 0, I do this, okay, else I do this, else I do this, okay, yes I do this, and that's it, and that's it, okay, and that's it. And it's a countdown yes will work, okay. So here let me put the exclamation mark to have 3, okay. So this one is a termination condition. N equals 0, you press off, and then you get out of function, and then you return. Okay, and then you return. So this one press off, yes, okay. This one will press off. If it's not equal 0, you count it, and then you count down, count it, and then after you finish the press off, you come back to C1. You do nothing and you get out. Okay, so that actually is fine. Okay. Okay, I'm sorry. Here I should not call countdown. I should call countdown yes. Okay. So you'll get a 3 exclamation mark. Okay. Any questions so far? This is another way to write this function recursively. First one, we have a term, you say this one called linear countdown. This one, we write the base condition at front, but you need to terminate it. This one, actually, I do the recursive version in the if statement. Okay, and I put the termination condition, base condition at the else part. Okay, either way, okay. Either way, okay. Any questions so far? How about Natasha? Is that okay so far?
Yeah.
Can you understand?
Yeah, I understand.
Sure, okay. So this you compare the countdown and countdown yes. Can I still write another version for this? Yes, I can still write another version. So public static void, okay. Countdown, yeah, version. Okay, so let's actually try this one. This one I will modify it a little bit. So I don't need this else. I don't need this here else. Okay, so here if actually n greater than 0, okay, we do this. N greater than 0, I do this, I copy the whole thing here. Okay, and here I say I'll return. And here I'm going to copy my termination condition here. I put it here. Okay, This one, because you have a return, so anything passed here, anything passing here, n will be less than equal 0. Only n less than equals 0, you will pass this line. Anything passing this line because of this return, n greater than 0, whatever they do, they will terminate. They'll terminate. So only n less than or equal to 0, you will go past this line. Okay, so this one for sure. This portion is termination condition. Okay, and this one you do recursive call, so that's okay. This should be the same as this one. Okay, so this one still can guard against it. This one I put the return on the recursive formula, but I got it. Okay, so here I'm going to put 4 exclamation mark on here. Okay, so this one is countdown ER version. Okay, so let's go to copy this one more time. This 4 version are recursion. You can write the recursion in this different way. Okay, so what I want to say is the recursion is not only one programming style. There are many programming styles. Okay, there's not only one programming style that call recursive call. No, there are several ways. Okay, at least I give you the countdown version. I give you the countdown yes version. I give you the countdown yeah version. Okay, all these are different way to write recursive function, and they are done in totally different way. Okay, any questions so far? Any questions so far? No, no. We'll continue. Okay. So you talk about so much. So why we need the recursion? Why we do need to have the recursive function? Okay, so let's try this one. Okay, let's try this one. Let's try here. We have a binary search. Okay, binary search. Let's assume that we are going to do binary search. Okay. So I write binary search in 2 versions. One is linear version. One is recursive version. So at this moment, because you are taking AP, you should be able to write the regular version. Okay. So here I have 1, 3, 5, 7, 9, 11. Okay, 13. Okay, 15, 17, 19. Okay, so I put the odd number here. So odd number will have hit. Even number will have miss. Okay. So I'm going to memorize my binary search function. So search, okay, integer array, ARY, okay, integer key. Okay, so you try to search key inside the binary search. So I'm going to memorize it. Okay, so you also need to memorize it, okay, by heart when because you are taking the AP exam. So integer low will be equal 0. Okay, integer high will be the last element. So it's ARY times -1, okay, and then while, okay, there's no crossover, so low less than equals high, no crossover. So if you get out of the while loop, it means low is greater than high. Then this is a crossover for low and high. Okay, this one we talked about it last time. Okay, so when there's a crossover, I return -1. Okay, I return -1. So that means that your data is not found in the array. Okay, so now over here I need to do integer. Okay, mean value equals half of the low plus high. Okay, this one you need to memorize by heart. Okay, and then if actually your ARY's mean value equals the key, then you will return what? Return the mean value. That's the index of the element you want to find. Otherwise, if your key actually is less than ARY's mean value, it's less than ARY's mean value because the array already been sorted. So it should be on the left hand side of the middle value. Okay. It is on the left hand side of the middle value, so we will do this one. Your high need to be mid minus 1. Okay. Otherwise, the key should be the right hand side of the middle value. So your low should be your mid value plus 1. Okay. So this is how I remember the binary search. Okay. This one we talked about it last week. Okay. So public static void name, the string array args. Okay. Okay, so here we actually print these. So I'm going to test different numbers. Okay, so I'm going to take system.out.print line print f. So here I say binary search of percentage d is percentage d. Okay, plus n. Okay, so here I search 5 in search of my array A and then 5. So that's actually is searching 5. I'll get some index. Okay, so let me search 5. Let me search actually 11. Let me search 4. Let me search 20. Search -1. Okay, so these are the different numbers I search. Okay, so these are different numbers I search. Okay, a search function must be stated. Okay, these are different numbers I search. So here I change this one to 11, this one to 4, this one to 20, this one to -1. Okay, so this one is a version of the search. Okay, binary search. Okay, so 5 in index 2 is odd number, yes. 11, yes. And these are actually even numbers, so not found. This -1 is out of range. Okay, so this binary search do work. Any questions so far? Katie, are you okay? Katie, wait.
Yeah, I understand.
Okay, now this one I'm going to write into binary search format, into recursive. I'm going to convert this one into recursive. Yeah, I call it binary search. The same array will be passed. Okay, integer key will be here. Okay, so I'm going to call this one recursive. Okay, but I have a key, but this one actually won't work, not easily work. So I'm going to pass the integer low and the integer high here. Okay, so if actually your low actually greater than high, in this case I'll return -1, not found. Okay, not found. Otherwise, I'll create integer value, mid value that is actually half of my low plus high. Okay, so this portion is here. Okay, this return is here. Okay. Okay, good enough, right? Good enough. Now we will do what? We will do what? We will do if actually ARY's mid value is equal to key. I'm going to return mid value. Okay. Else if actually key actually does that ARY's mid value, then I'm going to do return what? Return here we have this one, right? But I do not write this. I do return what? Return my bin search. Okay, my bin search on my ARY and the key and the same low and my mid value become high value become min -1. Okay, so this one is this one. Okay. Then when I do else, okay, here you don't have else, it's okay. With else or no else, actually okay. Yeah, because every other case they already return, so you don't need to care about it. I can directly return. Directly return, and I have this bin search. Okay, so here would be mid +1, and then high remain the same. This one I say exactly the same with the with this one. Okay, but here you have 4 parameters, so we want to have this a bin search. Okay, and then we call this one, but I don't want to have 2 extra parameters. No, I don't like that. And then here I'm going to do return, okay, bin search of the ARY and the key and the 0 and the ARY dimension. Okay, so this one is the main function for bin search. This one is the helper function for bin search. Okay, is that okay? So then I write this regular searching function into a binary search format, recursive format. Okay. So I'm going to copy the whole thing here. Okay. And put it over here. Okay. And here I will say system.out.print, separate line. So here I'm going to change the search to bin search. Okay, so I use a Control F. I have a search. Okay, I want to replace by bin search. So once. Okay, so this one I don't want to change, but it changed. I need to do it. Okay. Okay, good. Compile and run. Wait, there's binary survey, so some sort of error. Let's see what's wrong. Index out of bound. Index out of bound. It's an index out of bound issue. Okay. So why is that? Oh, this one I need to use a -1. Okay. I put a wrong number there. Okay, no problem. Let's try one more time. Okay. That's the high value you get, but these two are the same value. Any questions so far? Okay, this was for binary search. Any questions so far?
Can you explain why did you put return bin search instead of just bin search for the recursive version?
So can you understand this one?
Yeah.
Okay. So this one you set up this one first, right? And while this happened, okay, you do this, right? So here you initially put the low and high in this two values. So this call is equivalent to setting these two up. Is that okay?
Oh yeah, I meant the third.
Okay, and then you come to the inside here, right? You come to the inside. So you come to the inside here. So when there is crossover, we return -1. So crossover happen when this one have low greater than high. You bypass. So every time you while loop, you will get a new set of low and high. Is that okay?
Yeah.
Every iteration you get a new low and high. And when it's grow over than that, you return -1. Same thing here. Okay, same thing here. You look at the recursive function. Every time you get a new set of low and high. Once it's crossover, you return -1. The same, right? Otherwise, if there's no crossover, I calculate my v value. I do these two functions. Same as here. I calculate my v value. I do the 2 things. 3 things. Is that okay?
Yeah.
So here, let's compare these two portions, okay? So if I calculate the mean value, this is the set. And then if my mean value equals key, I return my mean value. That's actually the set, right? This one is the set.
Yeah.
So if my key is on the left-hand side, what I do is I update my high value. So I'll update my high value. So at the end of the iteration, I have a new set of low and high, and I repeat it again. Here the same, I update my low and high value. I call the function one more time. This one's by calling the function one more time. This one's by doing one more iteration in while loop.
Oh, what happened if you like got rid of the return in front of the?
If I don't get out of return, which return?
The else in the third function.
This one?
The line after.
The one
The else if part.
if I don't get this one?
Yeah.
If I don't get this one, I say I do this one. Okay, let's do this one. I have been search, right? It call in array and the key and then 0 and n-1, right? So it narrow down to B, A and K and the 2 and 3. That's assume that, okay? Let's assume that we're down to here. But we do have a hit on index 2. We do have a hit on index 2. So what? You do not return the value. How can this one get the return value?
Oh, okay. Oh, okay, got it.
You always have the return value integer there. You have to pass them back. Right?
Oh, okay, yeah.
Makes sense?
Yeah.
But how comes this guy do not need to have that? How comes this for loop do not need that? Because that always actually, you will always get a return value next time when there's a return here. It check this one, new low and high. You would check if it meet, you get it. If it don't meet, you get this one, okay? But this one is recursive code is different. You actually need to depend on the smaller case result. So this one is a binary search. So you originally have so many data. Okay, you hit the mean value, you don't know, but you need to get the data from here. So the data from here need to report back to you. All data from here, you need to report back to you. This one is recursive function. Okay, you break down your array to a smaller portion, but the result you get from the smaller portion need to return back to the main program. Okay, does that make sense?
Yeah, that makes sense.
And this one is a while loop, so you don't care. It go all the way, no data, then you get -1. It hit, it return already. Okay, it doesn't call anybody else, so the data you should get it right away. Okay, so this one just to show you every iterative function you can write it by recursion. Okay. Okay, so that's the binary search. Let's try a different one. Okay, let's try a different one. Let's just try here. We have sum function. Okay, let's do sum function. Sum function will be easier. Okay, will be easier. So that I'm going to write this as sum function in different way in recursive. Okay. So let's assume that I have a function sum. I'm going to calculate the sum from 1 to n. Okay. I'm going to calculate sum from 1 to n. So I have a public, okay, static, okay, integer sum of integer n. Okay, so I'll get sum from 1 to n. So here I will have, if n equals 0, I'll return 0. Okay. If n not equal 0, I'll return, okay, n plus sum of n minus 1. Okay, and this one will calculate the sum from 1 to n. So public, okay, static, and then void, and then, okay. So here I say sum of 5. Sum of 5 is 1 to 5. That's how much? that's 15, right? That's 15. Okay, so 1 to 5 is 15. Okay, this one work. But this one work, but there is a problem that you n plus this. This one is non-tail recursive. So we would like to modify it into a tail recursive version. Tail recursive will be faster. Okay, or better. So that means we write it into tail recursive version. So there's a static integer sum. Here I have an n, okay, and then I'll say integer accumulator. So how this one works is, if actually n equals 0, okay, I'm going to return accumulator. Okay. Otherwise, I'll return sum of the n minus 1, okay, and then accumulator plus n, okay. So this one again, this one is a helper function. Okay, because you add one more variable called accumulator. So now here I have topic, okay, static, okay, integer sum a. Let's assume this one called sum a, okay, sum a. So here I get integer n, okay, and here I have this one called return sum of n and then accumulator as 0. Okay. So this one, let's look at this one. Okay, let's look at this one. So my, okay, I'm sorry, this one should be sum a. Okay, should be sum a. So let's look at this one. Your sum a of 5 is calling sum a of 5 and 0. Okay, and sum a of 5 0 here. Okay, sum a of 5 0. Sum a of 5 0 will call sum a of 4 and 5. Okay, sum a of 4 and 5 will call sum a of 3 and 5 plus 4 is actually 9. Okay, sum a of 3 and 9 will call sum a of 2 and 12. Okay. Sum a of 2 and 12 will call sum a of 12 and 14, 1 and 14. Sum a of 1 and 14 will call sum a of 0 and 15. And then this one return 15. Is that okay? Any question? Any question? Hi, Lukma, are you okay? This one?
I'm okay.
Understandable?
Yes.
How about James? Is that okay?
Yeah.
So this one tells you 2 different versions to drive recursion, okay? The way one I wrote is actually recursive diagram. In the multiple choice, you need to write this pretty often, okay? You must be able to write this recursive diagram pretty often, okay? You need to do that, okay? You need to do that. So here, this one is a non-recursive version, and this one actually is slower, okay? And this one is actually faster. Recursive, tail recursive version actually is faster, okay? Okay, so here let's actually print out sum a of 5, okay? Print out sum a of 5. Okay, let's print out sum a of 5 and let's see what happened, okay? Okay, it's still 15. So these are 2 different ways of writing the recursive. One is tail recursive, one is non-tail recursive, okay? One is non-tail recursive. Okay, next one. Next one, we still have more, okay? Not done yet. So here I talk about why we do recursive because sometimes we need that for using recursive formula for taking data. Okay, and I told you different style to terminate your function. Okay, and I give you an example that to prove that most of the equation that you use in non-recursive can be done in recursive format. Okay, and then I go back to look at the tail recursive and non-tail recursive. Okay, now we are going to teach you recursive processing. So what is recursive processing? Recursive processing is let's do all kind of the algorithm that you write in the non-recursive version into recursive version. Okay, so let's do this one. We have a static integer array. Okay, a equals 6, 2, 1, and then 10, and then 9, 8, 9, and then 4, and then actually 5, and then 8. Okay, so 1, 2, 3, and 3. Okay, 1, 2, 3, 4, 5, 6. No 7, so 7. Okay, so here we have 1 to 7, 1 to 10. Okay, 1 to 10 in an array. We are going to do this one. Okay, so how about print function? That's print every data at a time. So static. Okay, actually void print. Give me the array ARY, and I'm going to print every element of it. Okay, so here let's do printing. So printing. Okay, here if actually I will need a variable called index. Okay, so index. So here, if the index is actually greater than ARY the length, okay, I'm going to do nothing. So here I do return. Otherwise, I'll do system.out.print line of my ARY's index value. Okay, and after that, I'll do actually run, continue to print from ARY, and then this one should be index plus 1. Okay, so this one actually is the way we print it. Okay, do I need to have a return here? No, I don't. Okay, only when we terminate the program, we actually do a return here. So let's do this one. Okay, this one will print out the whole thing in the array. Okay, but we are not supposed to have the index. So this one actually is only a helper function. Okay, so write your helper function first, because you may need extra variable. Okay, so here let me do print, one more print. Okay, so integer array ARY. Okay, and this one I'm going to call my initial condition. So here I would do print my ARY 0. Okay, publish static avoidment. Okay, so here so this one must be static. Okay, okay, so this one is printing the data. Okay, oh, how come I'm so stupid? Keep typing the same thing. Index of a bound. Okay. Okay, here I should have an equal sign. Okay. Okay, any question? Any questions so far? So I can print array using this one, okay? Okay, any questions so far? Hi, Amy, how are you?
Good.
Any question so far?
No.
So this is the way I write a recursive function to print out every element in the array, okay? So initial one, this one is similar to for integer I equals 0, okay? Same thing like that. And every time your index updated here. So this one is similar to index increase, okay? Is that okay?
Yeah.
And this one here is similar to 4, okay? The integer I equals 0, and here is actually index less than ARY.x. Is that okay? If it is not, you actually break it, right? You break it. Is that okay? Similar to this. Okay, so I'm writing this one in recursive format. Okay, next one, if we try to find the maximum value, okay, find the maximum value. So we do public, okay, static, okay, integer maximum value, okay, getting from the array ARY, okay, ARY. I'm going to find the maximum value, so I also need to have the index, okay, and okay, if actually index okay greater equals ARY the length, this one I'll return integer the mean value. Okay, so here, okay, so here I traverse from the first element. Okay, I traverse from the element. So you actually, if it's greater than that, I'm going to stop. Okay, I'm going to stop. So here, actually right here, I would have okay integer. Okay, I already should do return. Okay, return finding a maximum of my current value. Okay, and then here I would have the index. Okay, plus 1. Okay, I'll search for the index plus 1. And this one, I'm going to set it to n. I get the data and I call it n. Okay, I continue to search it and I get the n. So if actually m, actually, let me see, actually ARY, okay, greater than m, okay, I'm going to return, if this one, actually index value, I'm going to return, ARY of the index value. Okay. Otherwise, I'll return. Okay. I'll return if it's greater than the next call. Okay, the next call. The next call will get a better value from the next call. Okay, you keep getting to the next level, getting to the next level. Okay. So if my value greater than that, I will get this one. Otherwise, I'll return m. Okay, I will return m. So this one will get the maximum. Okay, so this one part 2. Part 2 is maximum. Okay, at the very end, actually this one is maximum, but this one is also a helper function. Okay. Okay, so here I should have a public, okay, static integer maximum function, okay, integer array, okay, and then I'm going to do a return, okay, this whole thing. I start from index value of 0. Okay. I start from 0, and then if it's out of bound, I return this. Okay. Otherwise, I would actually call the function for the next field. So basically, what happened is like I have an array. I have index 0, so I call the next one. So next one, the m represent the maximum on the right hand side. If my value greater than that one, I'm going to return my value. If not, I return the m value. Okay. Any question? So here I should have integer m equals the maximum of a. Okay. And here I will say system.out.print f. Okay. So here we have maximum of a equal percentage d. Okay, plus n comma maximum of the a. Sorry, just print the n. Okay, so print n. So maximum is 10. Okay, is that okay? Is that okay? About James B, is that okay so far for this finding maximum?
Yeah.
So this one actually is like this, okay? Originally you have some array. Let's assume that we have 3, 5, 1, 4, 2, okay? So you get started with the IDX equals 0. And this one compare with the subcase. The subcase actually is a maximum of the A, R, Y, and 1, okay? The index 1 and after. The index 1 and after, you get a value called M. That M compared with 3. Who is bigger? Okay, the bigger one will be returned. Okay, so this maximum array of 1 you call maximum array of 2 and get a different M. Okay, and that M compared with your ARY of 1 to see who is bigger. Okay, and that one will return as the M of that table. Okay. So this one is finding the maximum. Similar things I can do down traversal. Here, this one is up traversal. So how about here? Can I do this one? Can I do public? Okay, static. Okay, integer. Okay, mean value. Okay, integer. Okay, ARY. Okay, integer. Okay, index. Okay, so here I say if actually index equals 0, I'm going to return my ARY of 0 right away. Okay, that's my minimum value. Okay, so here the same thing, integer mean value will be equals minimum of my ARY. Okay, index minus 1. Okay, as a mean value. Okay, and then here I will have if actually ARY of the index, actually less than M, then I'll return ARY of the index value, otherwise I'll return M, And this one is a different way to write it, different way to write it. So here I have public, static, integer, mean value, integer array, ARY, Here I will call return, mean value of the ARY and ARY times minus 1, So this one is like this, This one is like this. I actually have an array 3, 4, 1, 5, 2. So I started with the n-1 location, the last one. So if this one is 0, I'm going to return itself. Otherwise, you'll compare the minimum of these and to see who is smaller. See who is smaller. And then I iterate to here compared to this portion, minimum of that. Keep doing that until I have only one element. I only have one element, then that element is the minimum. Okay, anyway, this one's a down traversal using the index 2 down traversal to find the minimum. Okay. So this one pass 3, okay. Find the mean value of the array. Okay. Okay, so that's wrong. What's wrong with it? Okay, so here let's do mean value. Okay, mean mi. It's okay. Minimum is 1. Okay. 5 digit and minimum is 1. Any question? Finding the minimum. Any question? So maximum, minimum, sum. I can all do it. Okay. And let's do sum. Now let's do sum. Okay, let's do sum. Do sum. We have public. Okay. This one I'm not going to use the index. I can use index, but I don't use it. Okay. So integer sum of the integer array a y. Okay. I just do this one. Okay. So here I'm going to do if actually I still need to have an index. Okay. I still need to have index. So here integer I. Okay. So if I actually greater equals ARY, then okay, I'm going to return 0. Okay. Otherwise, I'll return actually ARY's I's value plus the sum of ARY and then I plus 1. Okay. And here I get started with public, okay, integer sum of integer array ARY. Okay. And here I'm going to do return, okay, sum of ARY and starting from 0, index 0. So this one I calculate the sum of array. Okay, these are sum, maximum, minimum. I try to use different way to write it. Okay, in each way, 1, 2, 3, each way you can apply to other function. Okay, you can try to apply them to the different function. It should all work. Okay, so sum, what's wrong with sum? Okay, non-static. Okay, any question? $63. Am I typing something wrong? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have 2 8. Okay, let me delete 1 8. Okay, I have 2 8 as well. I should get 55. Okay, I should not get 63. Okay, any question? So you see, all kind of function I did it in the while loop, for loop. I can all write it in what? I can all write it in the recursive code. Can I do shuffle? Yes, I can do shuffle. So let's do shuffle. Okay, shuffle of the numbers. Okay. Okay, let's do shuffle. Okay, let's do shuffle. So shuffle, I still have a one index, okay? So here, if the index, okay, actually it's greater equals array.length, I'm not going to shuffle, okay? So here I do return. Otherwise, I will find an integer j, okay? I would find an integer j, and then this one actually is, I'm going to do j, okay, j is a value. Okay, so you every time you shuffle the I, okay, so you are going to your data starting from I, okay. So that's actually don't get it from here, okay. Let's get it from actually if this one equals 0, we will start, okay. If equals 0, we will start. So let's actually get from the right side, okay. Get from the right side. So right side you have index, okay. And you are going to shuffle with some number from here to here, okay? So basically this one, we will do this one, okay? We'll do j equals integer, okay? This is an integer. That actually is a master random, okay, times, okay, the index minus 1, okay? The index minus 1, okay? I'm sorry, this one is index, time index, okay? So index time index, and you do compilation. So this one is a number between 0 and index minus 1. Okay, it will be from 0 to index minus 1. So then we are going to swap the data in the index location and the j location. Okay, and j location. So we do this one. Integer, okay, integer temp equals ARY's index value. Okay, and then ARY's index value equals ARY's j's value. Okay, and then ARY's j's value equals 10. That's it. Okay. So now this is a shuffle function. We may want to have no index, so we say public. Okay. Okay. Void shuffle the array ARY. Okay. Okay, so here we are going to get the initial value for index. Okay, so this one, okay, I'm sorry, this one I'm going to do return. Okay, shuffle 5 ARY and ARY length minus 1. That's the first to be swapped location. Okay, first to be swapped location. If it is upon the right, so basically every time I pick a value on the rightmost value, and then it's going to shuffle something in here. Okay, you're going to shuffle something with something in here. This one you don't return, you just do shuffle. There's no return value. Okay, this is part 5 shuffle. Okay. So this one's part 5 shuffle. Okay. I miss H. Okay. I miss H shuffle. Before and after. Okay. Before and after. And here I do shuffle A. Okay. So here I don't have the arrays, so I need to import. Okay, java.util. Okay, so that I actually finish one shuffle. Okay, so let's run it. There's something wrong. Okay, missing the H. So right here, let's run it. Okay. Actually, it's almost no change. Okay. Wait, something wrong. Okay, let me check it. Okay. So here you time the x index, okay? Okay, you only call once, sorry. After this, I need to continue to do shuffle, okay? ARY and index -1. Okay, sorry for that. I only shuffle once, but I do not continue to shuffle, okay? Sorry, that's not recursive call. So I need to have a recursive portion. Okay? Is that okay? Is that okay? Hello, is that okay? Hello, is that okay? Any question? Okay, so this one is shuffle. But if I want to do this shuffle for 10 times, but I do not want to write for loop. Okay, I can find a loop to do shuffle for 10 times, but I don't want to do that. So let's actually do here. Okay. Okay, let's do execute. Okay. So execute if actually n equals 0. Okay, and then we return do nothing. Okay, otherwise we will execute. Okay, we will do shuffle. Okay, we'll do shuffle, and right here we're going to do shuffle. Okay, so here let's pass an array of integer array A. We're going to shuffle it. Okay, and then we do execute. Okay, and then here we have n-1. So this one is execute for n time. So this one here we do execute, okay, 10 times for A to do shuffle. Okay, so that is a simple way we do for loop, but I don't write for loop. I write a execute function only for n time, and you run shuffle. So here you see, I never use any for loop. So far, I write no for loop, not even one. I never write any for loop point, okay? And now do multiple shuffle, 10 shuffle. Okay, any question? So basically, whatever recursive function, whatever for loop, while loop, I can all do it using my recursive function. Okay, any question? No question? No question? Hello, any question? No question, we are going to continue, okay? Next one, I'll kind to find GCT, okay? This GCT, we worked on it before. So let's remember the so-called, we have several ways to do GCT, okay? GCT, GCF, Greatest Common Denominator, okay? So here, let's do this one. Let's work out the traditional iterative version, okay? So you have a GCF, okay? You get a number called M and integer N, okay? So here, if you are using non-recursive version, okay? So here you would have if while, okay? N actually greater than 0, okay? N greater than 0, we will do the following, okay? We'll do the following. We will do integer old m will be equal. We will do this one, okay? Okay, this is GCF. Let's actually explain it one more time. Okay, one more time. So we do have M equals AF. Okay, N equals BF. So M minus N equals A minus BF. Okay, so be A not equals B, then the GCF of M and N should be the same as GCF of N and M minus N. Is that okay? Is that okay? Hello, is that okay? Hello, is that okay? Hi, Katie, is that okay?
Yeah, I think so.
So you have two numbers. These two numbers difference. Okay. This difference will have the same GCD as the M or N. Okay. Okay. Based on this, we will say this one. If actually M equals not equals N. Okay. As long as they are not equal, I would say if actually M greater than N. Okay. Then we will say N actually M equals M minus N. Okay. Otherwise, I would say N equals N minus M. Okay. Whichever bigger one, and then when you get out, we return M. You return N or M is either the same. Okay. Okay. Before it's the same. Okay. So let's do this on public. Okay. Static. Okay. Void name. So this one will find your GCD. Okay, this one is finding your GCD. Okay. So system.out.print line. Okay, print. Okay, so let's try different GCD to be tested. Okay. Okay, so here we have system.out.print line. Print F. Okay, so the GCD or percentage D percentage D, okay, will be equals percentage D backslash N. Okay, so let's try 3248, okay, and then GCF, okay, GCF or 32 and 48, okay. Let's actually copy this whole thing one more time. Now this function must be static, okay. But this one is non-recursive version, okay, non-recursive version. So actually, we do this, okay. So here I change it to 48 and 32. So the order doesn't matter. Which one's N, which one's M, really doesn't matter. Okay, and here I change it to 65 and actually 52. Okay. Okay, and then I try to use a prime number. Okay, try to use a prime number. So this prime number is actually 97 and 84. Okay. Okay, we can test more pattern, but that's done up to here. Okay, this one is not recursive version yet, so it's just a GCF of the iterative version. Okay, and we got 16, 16, 13, 1. That's correct, right? That actually is correct. Any question on this one? Hey, Katie, are you okay?
Yeah, I get it.
How about writing this one in recursive? Okay, let's write it in recursive. Okay, so here, public, okay, static, okay, integer GCD. Let me use GCD because recursive version, okay. It means the same thing, okay. So here you say, okay, if actually M equals to N, okay, return M, we are done, okay. Otherwise, if actually M greater than N, okay, we'll do GCD of M minus N and N, okay. Otherwise, we will do return. Okay, here we will return. Otherwise, we'll return GCD or actually M and N minus M. Something like that. Okay. That's it. This one will also find GCD. Okay. So here is copy. Okay. Okay, here I change it to GCD. GCD. All the different function. Okay. Okay, this one why I emphasize so much on GCD, because this one in the real exam, it may show up many times. It may show up many times, but the result is the same, okay? Recursive version or non-recursive version actually the same, okay? And we use a successive subtraction way, okay? So this one really means that you have M equals A times the F common factor, okay? N equals B times the common factor, okay? So your M minus N equals A minus B, okay? Times common factor, okay? But we can update this one to include Euclid version, okay? So let's assume that M equals N times Q plus R. So M divided by N equals Q, okay, that's quotient. And then M take modular by N equals R. So R will be equals M minus NQ, okay. So here you actually what? Have this one is actually still multiple of it. So if you have M minus NQ equals actually A minus BQ times F, I would say this one should still be the multiple of the F. So originally you are trying to find M and N, so GCD, you become trying to find N and the R's GCD. Okay, and it would be R and M take modular by N. Okay, so this is the so-called Euclid algorithm. And we can also do it in recursive way, okay? So this one is actually have another version called public, okay, static, okay, integer, GC D, okay, let's put an X in there, integer M, integer N, okay, so here, if actually N equals 0, okay, we will return M, otherwise we will return, okay, we return what? We will return GCDX of the N, okay, and the M take modular by N is 2 numbers. Okay, that's it. That is the GCD of another version. That's a very short version. Copy these things, okay. Put it over here. Okay. And this one called GCDX, Euclid version. And it's still the same, okay? It's still the same. You still will find the GCD, okay? And we try this different version because it will help you later, okay? It's still the same. Any questions so far? It's a recursive version of the GCD and in different format, okay? Is that okay so far? So far, if it's not iterative version, I never use any while loop for loop, okay? So everything can be done in this way, okay? Can be done this way, purely recursive function, okay? Purely recursive function, okay? So let's do this, okay? We have enough of the recursive function, too many already, okay? So let's have a break, and then after break, we will work on a balance set, okay? So right now it's actually 7:35. Let's come back on 7:40, okay? And we will look at the problem set in parents' book. Okay. Any question? Okay, no question. We have a break. Okay.
Yeah, we can hear.
Please turn on your camera. Okay, so I can see you. We'll resume. Okay. Making sure you are actively participating in the discussion. Okay. The first part we talk about all kind of recursive. I think we had enough. Okay. So now we are going to work on the problem. Please turn on your camera, please, so we can see you. Okay. Otherwise, we even don't know whether you are there or not. Okay. Some people just run away and never come back. Okay. So please turn on your camera. Okay. Thank you. Thank you. Okay. Anyway, let's actually work on the first problem. Okay. Okay. First one, let me start it from the bottom. So have William. Okay. Williams. Let me see. William, can you work on the first problem? Hello.
Yeah.
Okay, work on the first one. Okay, this is only discussion, okay? So don't have too much pressure. I want you to pick up the exam taking skills. So what is the answer for this one? Which of the point about recursion are true and which one is wrong? So one true.
Yeah.
Every recursive can be written in iteration. Okay, yes, I proved it already. You actually can do everything using recursive. Okay. Two, tail recursion is always used in divide and conquer algorithm. True or not true?
Not true.
Why not true? Because tail recursion we can just use for sum, right? We never divide it into two parts, right? So
Yeah.
2 is wrong. Okay, how about 3? Recursive always defined in terms of a simpler case of itself, right?
True.
True. So the answer is D. Okay, the answer is D, 1 and 3. Okay. Problem 2, let me has Oscar. Okay. Problem 2. Here, okay, I'm sorry. Let me upload this file for you. So if it's too long, you can you look at your PDF. Okay. Sorry for that. Let me upload the file right away. Okay. You can go ahead. Okay. You can go ahead. While I'm uploading, you can go ahead. If you know it, okay. Okay, I'm uploading the PDF file. So please download it. It's too long. Okay, so here we do have it's still 1, 2, 3 problem. Okay, and he's trying to get a sum from 1 to n. So which of the 1, 2, 3 is correct? Is 1 okay?
No.
1 not okay. Why?
It's missing the end condition.
Is no base case condition. Yes. How about 2 and 3? Is 2 okay?
2 doesn't add anything together. It just added like n. So like n is the counter. It just adds the counter.
So 2 okay or not?
2 not okay.
2 actually okay. 2 actually okay.
Oh wait, no, sorry. Yeah, 2 is okay. 3 is not okay.
So why 3 is not okay?
Because 3 would add sum of n, right? The current one.
Mm-hmm.
Wait. Wouldn't m like calculate the sum over and over again? Like more times. Like it would take the sum and it would calculate it more times than needed.
Mm-hmm. And then
That's the problem with 3, so 2 is the answer.
3 will count more time. Only that.
Is there another?
It's not only counting more time. You have a sum of the 3. You call sum of the 3 plus sum of 2. Sum of 3 will call sum of 3.
Oh, it's an infinite loop.
Plus 2. Sum of 2 will also call sum of 2 plus sum of 1. And this sum of 2 will still call sum of 2. So it should never end and it keep exploding. Okay, so only two, only B. Okay, but everybody, if you don't have the PDF, please download. Okay, if you don't have a book or no PDF, please download. Number 3, let me have Natasha. Okay, Natasha Zhang. Okay. Will the function terminate without error or not? Yes or no? Or which one? Okay. Yes or no or none? Which one?
Is it A?
Only when input less than 15? No. You have string or empty string. You call this one, so it become 1 star. 1 star call in 2 star, 2 call 3 star, 3 call 4 star, and then up to 15 star. 15 star you don't print, but you still call it, so you call 16 star. 16 star calls 17 star. Keep going, never end. Never end. Even though bigger than 15 star, it won't print. It won't print, that means that you will return. Okay. So if you want to terminate a condition here, yes, you can put a break, or you can put a return. Curly brace with return there. It may break the function, but this one don't have that. So for non-string, you will never end, no matter what input string it is. E is the answer. Is that okay? Hi, Natasha, is that
Yeah.
okay? Okay, number four, let me have Luke Ma, okay? So how about this one? This one has the if now.
Let's see. If it's less than 15, it'll print out and then call it. Terminate without error. I'm gonna go with D.
Why D?
Well, if the length is less than 15, then it'll buff it up until it gets up to 15.
Mm-hmm.
And once it gets up to 15, it won't have anything to do then.
Mm-hmm.
So it'll probably terminate then.
Probably or for sure.
Definitely.
Yeah. So right now the key point is that, okay, don't get bothered by this print. Print has no effect. We only talk about terminate or no terminate. So print totally have no effect. Okay. So here you have a 15 as a boundary. Anything starting from 0 to 15, you keep increasing the size until 15, and you will stop. You will no longer call. Anything greater than 15, do nothing. So for all string, it will stop. Is that okay?
Yes.
Any strings equal or longer than 15 will stop, do nothing. Everything less than 15, you will actually become longer and keep calling the next longer one. And then you will not grow if it equals 15. Okay. So every single one. This one, let me have KD Wei, okay.
Let me read the question.
Number 5.
think it's B.
Why is B?
Because if you just like plug in result 5 and
Okay, plug in result 5. What will happen? Plug in result 5.
you go to
Mhm.
it'll go to 2 times result 4, and then
Mhm.
that becomes, and then result 4 is 2 times result 3, and then result 3 is 2 times result 2, and then that's 2
Yeah.
times 2.
So what's the function here? What's the result function? It should be h is 2 raised to the power 5, right? Result 5 actually is this. So result n is 2 raised to the power n. Is okay?
Yeah.
So this one you can draw the recursive diagram like this. Result 5 calling 2 times result 4, calling 2 times result 3, calling 2 times result 2, calling 2 times result 1. This one's 2, and then 2 times 2 equals 4, and 2 equals actually 8, 2 and 2 equals 10, 2 equals 32. That's one way you can solve it, okay? From top down, you can solve it. From bottom up, result of 1 equals 2. Result of 2 equals 2 times 2 equals 4. Result 3 actually would be equals 8. Result 4 would be equals 16. Result 5 would be equals 32. So from bottom up also can solve the problem. Which one better? Bottom up better in this case. Right? Right?
Yeah.
Okay. You can from 5 calling to 1 or 1 calling to 5. In this case, 1 calling to 5 is better. Okay. Number 6, let me have James D, okay. Okay, this one actually I already said, actually this one is how many times will the result be called?
Would it be B
No, this time is
or no?
asking how many times.
Oh,
How many times result will be called?
n times then, right?
N time, you have the R5 calling R4, calling R3, calling R2, calling R1. Totally 5 times. Okay. C. Next one, we have the mystery function. And this mystery function does has Henry. Okay. Henry, you look at this one.
Is it B?
B. Okay. So this one, how to can solve it? How can you solve it?
Well, basically, it goes to the else statement, and then it says return D plus mystery, etc. And so it'll be 6 plus 6 because n is equal to 2. And then when n equals 1, you return a equals 2. So 6 plus 6 plus 2 is 14.
Okay. So this one you probably need to write the so-called recursive diagram. Okay. So you have mystery of 3, 2, 6. This one calling D right now is 6. Okay. So it's calling mystery of the 6 plus mystery of 2, 2, 6. Calling 6 plus mystery of 1, 2, 6. This one you get 2. So actually it's 14. Okay. Is okay? So the equation actually is 2 times n, 2 times d. I'm sorry, it should be n minus 1 times d plus a. Okay, that would be the result you should get on this one. Okay, does that make sense? If you try to find a formula for this one. It's actually like this. Okay. So this one you got 14b. If you trace back like this, okay. But the formula you can use is this one. Okay. Next one, let me have Grace Jean. Okay. Number. Okay. How many call? What's the value return? This one we finish. Let's look at number 8. What would be the result of F68? Hmm?
Give me a moment.
So you can draw
Is
the
it 2? I mean, is it D?
D, yeah. So there's one way you can use the so-called recursive diagram, right? Is that what you use?
Yes.
So F6A calling, F62 calling, F42 calling, F22. Okay, you got 2. Okay, so that's D. But I would say I don't calculate it. I don't look at to the recursive diagram. Can look at the number and I'll select D. Why? Why I can just select D without even doing recursive diagram? I would say that. Grace, why?
What do you mean, why?
Yeah, I asked you why. Why I say that I could directly look at the number and I will pick D already. I don't need to write the right hand side recursive diagram, even though that's a good way to write it. But here I don't need it.
You go to the else case and then the else case directly.
No. I even don't trace it. Let me tell you, this F function is a GCD. This F function is a GCD. I spent about 30 minutes to talk about GCD, right? And actually the F function actually is GCD. Let's look at one more time the GCD. I'm not kidding. I don't waste my time talking about GCD. For GCD, there's a version, you do this. And that's the this version. It is the version that we talk about here. Compare this version and this. You got M is your K, N is your N. If the 2 equals, return M, return the K. Otherwise, for bigger one, you actually do this, or you do this. Is that okay? I told you I'm not wasting my time. This 2 actually is one same function. That's great. Is that okay?
Yeah.
That's why I told you I even don't need to look at code. It's I look at these 2 numbers, I know it's the GCD between the 2. Okay. So sometimes they put it as a M, sometimes they put it as a mystery function, but GCD is very oftenly called. Okay, oftenly look at. Okay, good job. Next one. Next one here we have the recursive function. This one for Eric U. Okay. So what does this one really do here?
I need a sec to open the file.
Yeah, open the file, please. Any question? Anybody has any question? Okay. While your friend trying to answer the question, you can also voice out your opinion. Okay, and you can also participate in discussion. It doesn't mean that only him or her is actually working on it. Okay. So what does this function really do? You actually only need this part, okay? So you have an array, you are given an array, right? And what is this number n and what's the return value you will get?
I think the answer is A.
Yeah, and then the n is the length of the array. So you pick the n-1 location, that's the last element, to compare with the winner of the left-hand side. That's called T. So compare this current array, current element with the T, see which is bigger. You return the bigger one. Yes, you return the largest value, but will not change the result of the content of the array. Okay? But it's still backward traversal from the end, left-hand side end. Okay? Anybody has a question on this one? No? No question? Okay, no question. We are moving on to the next one, number 10, okay? Number 10, let me have Damon Wayne, okay, this one. Print string.
Okay, 1 second. A.
Hmm?
A.
No, it's not A. It actually is B will print in reverse order. Okay, let's look at it. If you have A, B, C, D, right? So you will call A, B, C, D, you call B, C, D, and then print A. B, C, D call B, C, and C, D, I'm sorry, C, D, and then print B. And then C, D call D, and then print C. So call D, you will actually print what? Actually, call D, you will actually print D, actually call print empty string and print D. Empty string do nothing, you print D, print C, print B, print A. So you get D, C, B, A. It will be the reverse of the string. Okay?
Okay.
So how to print the regular string, not reverse? You can move this one in front of the print string. Now print out the first character first before calling others. Is that okay?
Yeah.
If you don't want to reverse, you need to put this one here. Okay, number 12. Number 11. Number 11, let me have Amy, please. Amy.
Okay, give me a second. Would it be A?
So this one, you have B and exponent. So B to the power 0, you get what? You get 1.
1.
b to the power n will be equals b times b to the power n minus 1, right? When
Yeah.
n greater than 0, okay?
Yeah.
So now if your number is b raised to the power minus n, okay, minus n is negative, okay?
Yeah.
We know that. So this one, let's assume this is e, okay? E equals minus n. E equals minus 1, let's assume that we have b minus 4, it will be equals 1 over b times b raised to the power minus 3, right? So this one to this one is exponent plus 1. So it's a. Is that okay?
Yeah.
3 cases, exponent greater than 0, equal 0, and less than 0. Okay? Very good. Thank you. We go back to William. Okay, William number 12. Hi, William. Hear me? Hello. Hear me? Hello. Hi, William. Are you there?
Oh, yeah.
Okay. Okay, so number 12. Okay, William, please. How to solve this problem? So you have a D3. D3 should call what?
If 3 is greater than 0.
You
Yeah.
do what?
What?
And you call what? D3 call what? Do something 3 call what?
It's what do you mean? Like the if loop?
What do I mean? I say D3 function calling what function?
Do something?
It called do something 2 and printing 3 and then do something 2.
Yeah, so A.
And then after that, what should happen?
It does do something 2.
Do something 2 call what?
Do something 1.
Do something 1 and then
Print 2.
print 2 and then call do something 1.
Yeah, and then it just, yeah.
And then do something 1 call what?
Do something 0.
And then
Nothing gets printed out.
no, you print 1. Why nothing print now?
Yeah, 1.
And then do something 0. And then so this one the same as this. So you print now 1 in the middle. So this whole thing print now 1 to 1. So it would be 1 to 1, 3, 1 to 1, C. Okay.
Yeah.
Okay. You need to work harder. Okay. Next one, actually, Oscar, number 13. Okay.
That's long.
Okay, number 13. This one a little bit harder. Okay. Oscar, hear me?
Yeah.
This one a little bit harder. Okay. But take your time. Okay. No rush. So here, basically, you have a right even function. You're taking a number, and then if it is not equals 9 minus 999, you are going to continue. Okay. So what's the nature of the right even?
The what? Sorry?
What's the nature of the right even? What does the right even do?
Just basically picks out all the even numbers. It chooses all the even numbers.
Not only that,
Huh? Sorry.
Not only that,
And then it prints them out in the reverse order.
it print out the even number and then continue to request for a new number. If it doesn't see the -999, okay?
Oh yeah, until it sees the -999.
Yeah, so which one is the answer? Is 1 okay?
So the first one's gonna check if it's divisible by 2, and it's gonna print it out. And it's gonna call right even. The first one is fine.
Mhm.
The first one should be fine.
The first one actually is wrong.
Oh, wait,
Wrong because of what?
right even. It calls right even. Number. Oh, it doesn't have. Oh no. Number 2. Oh wait, no. Right even should come before your print statement.
The 1 is not in reverse order.
Yeah, because it's gonna print them in the normal order.
Yeah, it's all printed in normal order. This one we see in the previous problem. We have a previous problem over there. This one, right? This one you want to have a reverse order. The call should be, the print should be after the call. Okay, you will be in reverse order. But here you print first and then call. That will give you the normal order. So this one is a typical case of having the regular order. So 1 is wrong. So is 2 okay?
2 isn't okay.
2 wasn't okay. Why?
Because it's calling right even before you even do anything. So it's gonna check if it's divisible.
Call the even right even before the printing is okay. That portion is okay.
But it shouldn't be inside the if.
Why it shouldn't be inside here?
Because then the user is gonna enter a number, and then when you call right even, it's gonna check. It's gonna check the new number, but it won't. Oh no, because right even. Again, it's gonna go back.
What's wrong with this if statement? Okay, the if statement is something wrong, but what's wrong?
Right even should be outside, but I'm not entirely sure why.
And what's the difference between outside and the inside?
When it's inside, will it do the check for the wrong number?
No. So you have 1, 3, 5, 2, 5, 2. You see this 2,
Yeah.
right? You will continue.
Oh, it's gonna call for.
If you see an odd number, what will happen if you see an odd number?
Then it's gonna say that is not true.
No, you will actually print it and never continue to ask for number.
Oh.
Right?
Yeah.
You get an odd number, you never ask for the next one, and it's already printed. So number 1, odd number, it should not be printed, but it will be printed. We only would actually pick up the even number and print. So number 2 is wrong. Number 1, you print odd number. Number 2, when you see an odd number, it's not going to request for the next number. So that's why I asked you, what's the nature of the right even? You need to understand the nature of the right even. The right even is that you see a number, you continue to request for the next one. Okay, you keep going that until you see a -999. Other than that, you should print out the reverse order of the number. So number 3 is the right way to do it.
Okay.
Okay, you continue to request for every number. If the number actually is -999, I stop. Otherwise, I will keep asking for it. And when I return, I print out the number, so it will backward print out the number. So 3 is correct. Okay. Okay. This one a little bit harder, but you try to understand. Okay. So number 14. Let me have Natasha. Okay. how to solve this number 14. What is mystery of 3? Hello, hi Natasha, hear me?
Yeah, give me a second.
No problem. I just want to make sure you are wrong, okay? This one is a little bit like Fibonacci number, okay? So you can do top-down traversal, you can also do bottom-up traversal. So Natasha, which way you like, top-down or bottom-up?
Sorry, what was your question?
My question is that this problem can be solved in top-down or bottom-up. Do you prefer top-down or bottom-up?
Top down.
Okay, let's try top-down. So mystery of 3 will call what?
Else.
Call what?
So mystery 2
2 and mystery of
0
0. Okay. A mystery of 0 call what?
is 2 and 2. Oh yeah. Mystery -3, 2 and 2.
Okay, so this one get 4, right?
Yeah.
Mystery 2 called mystery of 1. And mystery of -1. This one also called get 2, right? Mystery of 1 calling mystery of 0 and mystery of -2. This one is also 2. This one 4. This one 6. This one 8. This one 12. Is it okay?
Yeah.
Okay. So the answer is A. That's one way you can do it. The other way you can do it is you have mystery of negative number. You got 2. It's said here already. Mystery of 0, you get -1 and -3, you get 4. Mystery of 1, you get 2 plus 4, you get 6. Mystery of 2, you get, I'm sorry, you get, you actually get 6 plus 2, that's 8. Mystery of 3, you get 8 plus 0, you got 12. So top down is more difficult. Bottom up is easier in this way. Does that make sense?
Yeah.
Okay. So problem sometimes recursion, you can use an iterative way to solve it in easier way. Okay. Okay, this one number 15. Let me have Luke Ma. Okay.
Right. What will be returned?
P5.
Okay, I'll need to get some paper out for this.
You need paper and pencil, yes.
Okay, just a minute.
This one is also similar to Fibonacci number, right?
Yeah, just a minute.
Except that there's a minus sign.
Yeah.
Yeah.
2 minus. I got E -4.
How to solve it?
Well, that when T5 is called, it calls T4 and 3, and 4 calls 3 and 2. 3 calls like yeah, T3, and then 4 calls 3 and 2. 3 calls 2 and 1. And then the original T3 calls 2 and 1 again. So that 2 returns 4, minus 2. And then 3 returns 2, and then the 2 next to 3 returns 4. So 2 minus 4 is -2, minus 2 and 1, which returns 4 and 2. So -2 minus 2, which ends with -4.
Okay, so complicated anyway.
Yeah, that was pretty confusing.
No, it's not confusing. You use a button up would be easier.
No, I meant my
tier 1 is
explanation.
equals 2. No?
Yeah, I meant my explanation was confusing.
Your explanation, no. Actually, you use a button up would be easier. T of 1 is 2, T of 2 is 4. T of 3 is this one minus this one is 2. T of 4 is this one minus this one is -2. T of 5 actually is this one minus this one is -4. Nice and easy. You're using the wrong way to do it.
Okay.
Right?
Yeah,
Am I correct? Am I correct?
Yeah, that makes sense.
So I told you before you go into recursive code, sometimes button up is easier. Everybody here, this James, you hear this one?
Yeah.
Pay attention, okay? Everybody pay attention. It doesn't mean that you have recursive, you must do top down. Doesn't mean that, okay? This one show you another example of doing button up is faster. Okay, next one we have Henry, okay? This one's Henry. Okay, so Henry, how many calls for T6 now? Henry, hear me? How many calls for T6? How to solve it? Okay. Please work on this one, okay? Okay, let me have the question to work on this one, okay? I don't know where you go. Grace, work on this one, okay? How to solve this one?
16.
Yeah, that's 16. The previous 15 is using the getting the value. The value you can do button up. So how about how many call? How many call can you do button up as well? Yes or no?
What do you mean?
Well, you require to work on the T6. So they will ask you how many function call of the T will be made.
Okay, give me a moment.
You can do top down, you can do button up. Can you do button up?
Yes, you can.
Yes, you can, yes. So how to do button up? So T1, how many call?
T1, you will have 1 call.
1 call. T2, how many call?
1 call.
T3, how many call?
2 calls.
3 call. 1 plus 2 plus call T1, T2, T3 call T2, call T1. So totally 3 call because your T3 calling T2 and the T1. So sorry, 1 call, 2 call, 3 call, 3 call. Got it?
Okay.
T4, how many call?
4.
5 call. 3 plus 1, 1 plus 3 plus 1, 5 call.
I see.
T5, how many call?
6.
9 call. 3 plus 5 plus 1. T6, how many call?
14.
15. 5 plus 9 plus 1. Always need to plus itself. Is okay?
Okay.
Always need to plus itself. Let's do this one more time, okay? Do this a number of call another time. So starting from bottom up, T1, how many call? You call is yourself. You need to call T1, so it's 1 call. T2, how many call? You need to call T2, 1 call. You get a value. T3, how many call? T3, you need to call T2, call T1. Okay, so when you call T1, you get 1. When you get call T2, you get 1. And then combine 1 plus 1 plus the call for T3, so the total is 3 call. T4, how many call? T4, you call T3 and the T2, okay? So T2, you have 1 call, T3, you have 3 call, plus the T4 call itself. So 1 plus 3 plus 1 is 5 call for T4. T5, how many call? You call T3, T4, 8 call, plus the T5 call by itself, you have 9 call. T6, how many call? You have call 5 calls, 9, and then plus 1 more call by itself is 15 call. Answer is D. Is that okay?
Yeah.
Okay, this is a better way to calculate it. Okay, so here I show you this same backward calculating for tabulation to get the value. Okay, so number 15 is backward traversal to get a value. Number 16 is backward traversal to get the bottom up to get the number of call. Okay, remember the technique. Okay, it will save you a lot of time. Number 17, let me go back to Eric Yu, okay? Eric, hear me?
Yeah, I'm looking at the problem right now.
Yes. This one is a little bit tougher, okay? This one we call it coroutine. This one we have an academic term called coroutine. So what is coroutine? Coroutine means the f function calling g function. G function may call f function, okay? Two functions calling each other, we call it coroutine. But this coroutine is doable. You're just following the recursive diagram, you should be able to solve it. Okay, are you okay?
Yeah, I'm still working on it.
Take your time, okay?
I think the answer is E.
The answer is E. So what do you do to get this one? You do recursive code diagram. So let's have f of phi 3, f1 of phi 3 will call what? We'll call what? Hello, hear me?
Yeah, I hear you.
So f1 of phi 3 will call what?
We'll call 5 plus f2 of 4, 3.
And this one will call what?
4 plus f1 of 2, 3.
And this f1 will call what?
We'll call 2 plus f2 of 1, 3.
And then,
Then you'll get 4.
okay, and you return this one 6, return this one 10, return this one 15. Okay, so that's E. Okay,
Yeah.
so next one, demo, please. Demo win number 18, okay?
Okay. A. Is it A?
So why A?
Because F00 times F03 plus F04 equals to 15. F00, basically the factorial, I guess.
And
Then
then how do you pull up f over 15 equals that?
then afterwards it's just factorial 15 times so it goes back to 14 times FOO and go back to 13. So basically 15 times 4.
No, you do not actually show. I don't get the idea of why it would be equals to this one. Okay.
But isn't it, if it doesn't equal to 1 or 3, it goes back to returning. So it's in 15 times 14 times 13. So it's the factorial of 15.
How can you pull that if you will actually go back to time that?
Wait, sorry, what?
How do you actually will get that? Okay, so you have the factorial of this. How can you pull that it actually should be this value?
Oh, so it is FO 15 equals to 15 times FO 14.
You can only
right?
know that FOO of 15 equals 40 actually 15 times FOO of 14, and then
Yeah, then FO 14 goes to 14 times the FOO 13, right?
okay, and then
Then goes all the way to FOO 3, which after that is just 15 times 14 all the way to times 3. That's just 2 times 1, so it's a factorial of 2 at the very end.
F3 equals what?
F3 equals to just 2 times 1.
Who say that?
Because FO,
F3 equals 3. Who said that 2 times 1?
and then wait, but
F3 equals 3. How comes it's 2 times 1?
FO3 equals to
3.
3 times FO2, right?
No. Who said that? FO of 3 equals 3. Who says that 3 times something?
Oh,
Don't you see this one?
oh yeah. Well, okay.
So that's my question. How do you prove that it's A?
Oh, wait, so FO3 equals to 3.
Yes?
FO. So it just goes back then. FO4 equals to.
Okay, anyway. This one, I don't say this one's easy, okay?
Oh wait, I think wait, FO4 equals to 4 times FO3,
Yeah,
which
and then
is
F of 3 equals 3.
oh,
what?
so equals to 12. Then 12 plus 3 equals to FO15.
Yeah. So how to prove that F over 15 equals 15 pen over 2 pen? How to prove it?
FO15 then it's just 15 times FO14.
Okay, I'm going to tell you how to derive it, okay? Anyway, F of 1 equals 1, F of 2 equals 2 times F of 1 equals 2, F of 3 equals 3, okay? So 1, 2, 3 equals 1, 2, 3, okay? And after that, you have FOO of 4 equals actually what? 4 times FOO of 3. Okay, so this key point is this 3, actually it is equal to 3 pen over 2 pen. So FOO of 4 equals 4 times 3 pen divided by 2 pen. So FOO of 15 equals FOO of 14 times 15 equal blah, 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 down to, so it's 15 down to actually 4 times F3. F3 is 3 pen over 2 pen. So that you will get this, okay? Now, two things that F over 3 equals 3. F of 4 equals 4. Equals 12, I'm sorry. So these are two things, plus together you get 15. Okay, and then you can pull out this one equals that. So if you really follow the step, you will get a solution. If you just look at the answer, you don't know why it is 15 over 2 pen. Okay, don't do that. Don't check the answer before answering. We are discussing, okay? Some students just run away and some actually check the answer. Both are not the right attitude to review problem, okay? You can be wrong, it's okay, we okay for that. But if you want to do review, please look at how to solve the problem. This one again, same thing here. Do not use top down. You actually are fooling yourself. So I don't think that it's okay you start to tell me that I'm doing FOO 15, so this, no. It won't work that way, okay? It won't work that way. You should get from FOO 1 equals 1, FOO 2 equals 2, FOO 3 equals 3, FOO 4 equals 4 times 3 equals 12. So doing here, you already see these two numbers plug in 15, and then you do backward traversal, go back. But Key point is your f over 3 equals 3 band over 2 band. If you don't see this one, you are not going to derive this solution here. You don't see that. Okay? So this one, if you do top down, you're not going to be able to see the solution in this one. Okay?
Yeah.
I don't say this is easy, okay? This one's a hard problem. I don't say it's easy, but must follow the procedure to solve it, okay? Okay, next one, we have, go back to William, okay? Number 18. And none of these problems are easy, okay? So I don't blame you if you are wrong, okay? But don't jump step. You cannot do it, it's okay. We are okay with that. We are discussing the problem, okay? So William, number 18, okay? These parents for recursion right here, none of them are easy, actually. The bottom 10 problem quite difficult. Number 19, okay, I'm sorry, number 19. Number 19 is integer formatter problem. But remember, okay, sometimes if you do top-down traversal, you cannot solve it. Try bottom up from smaller number to backward to get the answer, okay? That's the key I can tell you today. Many of the problems doing bottom up is easier than top down. Okay, number 19, William, are you okay?
I'm still figuring it out.
First, tell me what are they doing right here, okay?
B.
D. So what are
B for B?
Boy?
Yeah.
So tell me what's the feature of the right 3 digit? What does the right 3 digit do?
It prints out the hundreds or like the second digit, and then
it print out the last 3 digit.
Yeah.
Okay, no problem. Let's print out the last 3 digit. So what does a right with comma do?
It adds a comma every 3 numbers.
Only that? So
yeah.
So if I have a number called 1, 2, 3, 4, 5, 6, 7, 8, 9, what will be printed?
One, 2, 3, comma 4, 5, 6, comma 7, 8, 9.
No. It will give you 7, 8, 9, 4, 5, 6, comma 1, 2, 3.
Oh.
So you actually divide by 3 digit and reverse order by the right with comma. You will do that. Why is that? Because you actually you see this one, you do write the digit for the 3 first. That is n 10 modulo by 1000, that's this one. So you print out this one first. Is that right? And then you print comma. And then you divide by 1000, so you get this yellow one later. You continue. And you recursive calling it, so you actually would do this one, and then eventually this one. Okay, so it's wrong. If you switch these 2 statements, it will work out perfectly fine as what you say. Is that okay? If you switch this statement, you will work out perfectly fine as what you say. Does that make sense?
Yeah.
Okay, so now, which one won't work out fine?
To be honest, I just looked at like basically if it's less than 1,000, it prints out fine. So
Mhm.
A and E are out, and then C and D are like the same. So like using the process elimination, I guess just the one with like
No, basically answer
8.
is C is wrong.
Oh,
Why is that? You have 1, 2, 3, 4, 5, 6, 7, 8, 9. You will reverse it, so you become 7, 8, 9, 4, 5, 3, 1, 2, 3. So if the number is a 3-digit palindrome, it should be okay. What is 3-digit palindrome, such as 251, 146? I'm sorry, 251, 462, 251. Your 251 swap, but it will still work. Okay? It will still work. 3-digit palindrome will work. Only 3-digit, that's a 3-digit palindrome. E also 3-digit palindrome. D you swap is still 3-digit palindrome. B also you swap 251, first 3 1 and 3-digit, and the last 3-digit is still the same. So B is also okay. Only C you cannot swap. 3-digit left and right different. Is that okay?
yeah.
Okay, so this one, okay. Key point is that, okay. Number 20, let me have Oscar, okay. And I actually already tell you the answer. The answer is,
Wait, I have to read the options.
hmm?
Oh, I have to read the lines. I didn't read the different options yet.
Yeah.
Wait, what do they call it? 3 digits. Interchange line. No. Wait, it was A, right? Oh no, sorry, not A. B.
Yeah, actually just swap the last two, these two statement, okay?
Yeah.
Because I told you it's a 3-digit palindrome. It actually swapped it. It's a reverse order of 3-digit, every 3-digit, okay?
Yeah.
So the answer is B. Number 21, I would say too complicated, okay, too complicated. So this one, just know is that the answer is B, okay? I don't think the real problem will test this one. This one probably take 10, 15 minutes to solve it, okay? This one take too long, okay? So anyway, this one's B, it's B, okay, boy, number 21. Okay, so the recursion, when you go to the problem, is not that easy, okay? Usually really confusing. So we still have around 10 minutes. So let's see, first, any questions so far? Not only today's topic in general, any question about the AP ComSci A, okay? Any question?
Can you show how to do bottom up recursion again really quickly? Because I'm still sort of confused on that.
Can I show you what?
Like an example of doing bottom up recursion.
Bottom up recursion? Bottom up is to trace the problem, okay? To trace the problem. So let's go back to the problem set one more time, okay? Go back to problem set one more time. We have several problems, okay? So see this one, number 5, okay? We have this result. It's not really, okay. You need to call result 5, but I don't need to call result 5. I can do directly see result 1. Result 1, is that legal? I just calculate result 1. Yes, so I get 2. So then I can call result 2. Result 2, because I know result 1. So 2 times result 1, I get 4. Right? So far, okay?
Yeah.
And then I call result 3. Result 3 is actually 2 times result 2, so you actually get 8.
Oh, okay.
So you keep going to do that, you actually end up with no problem reaching result 5. And isn't that easier than you call R5 and then call down? You know what I'm saying?
Yeah.
So this way more manageable and easier. Okay, this one probably not that obvious, but let's look at more complicated problem. This one actually not that obvious. Let's actually go to the more complicated problem. Okay, so let's go to say not this one. Okay, this is a mystery. Okay, this is a mystery problem. You need to call mystery 3. Okay, so if you do top down, you end up mystery 3 calling mystery 2 calling mystery 0, mystery 0 calling mystery -1 calling mystery -3, your mystery 2 calling mystery 1 calling mystery -1, your mystery 1 calling mystery 0 calling mystery -2, your mystery 0 calling mystery -1 calling mystery -2. So you actually have how many call? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have a totally 11 call, right? Quite many of them. And you sum up, you get the answer right. But let's look at the tabulation. We have the M call of the negative number is O2. Based on this condition, we know it already. Mystery of 0 calling 2 mystery of negative numbers, so it actually is 4. Mystery of 1 calling mystery of 0 and -2, so you get 6 over here. Okay, mystery of 2 you call mystery 1 and a mystery number, so you get A over here. Mystery of 3 you call mystery of 2 and the mystery of 0, you got 12, so you get the answer right away. How many of them? 1, 2, 3, 4, 5. 5 operations you're done. Compared to 12, 11 call. You know what I'm saying?
Okay, yeah, I got it. Thank you.
That's why this one is faster. Right? Same thing when we go to this one. Okay, this one also is broad. Okay, go to this one, full function, same thing. Okay, you go top down, you lose the sense of what it is. You really cannot understand what it is. But look at here, you have f of 1 plus 1, 2 equals 2, 3 equals 3. Okay, one thing you must remember that this 3 actually is 3 band divided by 2 band. That's an observation. Okay, this one you must know it. You know that the other one actually is F15 is equals n times F14. That is true. Okay, this one because it call everything is true. Okay, so when you have the 15 band, it is 15 times 14 band. Okay, and they keep doing that. You have 3 band equals 2 band. Actually 3 times 2 band. Okay, so that we know. Okay, but full function full 15 equals 15 times full 14. Okay, and you keep doing that down to full of 3. Here, this one is 3. Okay, it actually is 3. So compare this one to this one. What happened? You do see F3 equals 3 band divided by 2 band. Is that right? Then your F4 equals 4 times 3 band divided by 2 band equal 4 band divided by 2 band. Going up, you get a final solution. Is that okay?
Yeah, so you just usually just start with the.
Usually going bottom up is faster than top down. Most of the cases, I would say. Is that okay?
Okay.
Even though computer do recursive is top down. You know what I'm saying? Even though when computer do recursion is top down, but usually when you solve the problem, button up is faster. Okay. Okay, any more question? Hello, any more question? No question, no question. I'm going to write a last program for recursive, okay? And this one, because we have this 3-digit problem, this 3-digit problem, so I'm going to show you a recursive version of doing that, okay? So this one I'm going to, not exactly, but it actually is successive division, okay? So here, if we need to actually convert, okay, convert. So I'm going to convert a decimal value to binary, okay? So decimal value to binary. So here I have public, okay, static, okay, I have a string, okay, to binary. So I got a number integer here, okay? And then if actually n equals 0, I'm going to return 0 string, okay? This one, 0's binary term is 0, okay? Okay, and then actually I would do the following thing, okay? I'll do here, if I have 50, let me use a 13. 13 divided by 2 is actually is a 6 remainder 1. Divided by 2 it actually is 3 remainder 0. Okay, divided by 2 is 1 remainder 1. So I do it from here to here. Okay, so that's the algorithm we have. So here we have a actually string return string is empty string. At the very end we will return string. Okay. Now I do while, okay, while n greater than 0, okay, I do the following thing. So this number right now is 13. So every time I take the remainder, so integer remainder, okay, digit, okay, digit would be equals n take multiplied by 2. That is divided by 2's remainder value. Okay, that's the remainder value. So that's this one. Okay, the first time is this one. Then my return string, okay, will be equals this value digit plus the remaining string. So say I originally already divide by 2, I get a 1. The next 0 come in should be before 1. So it's 0, 1, the digit before it. Okay. And then my n actually would be divided by 2. Okay. So by doing this, I will get the 2 binary strings, so public, okay, static, okay, void main. So here I will do system.out.print line. Okay, so here I do have 2 binary for my 13. Okay. So this one will give you the binary format of the 13. Okay. Okay, so that's the, it's a binary value. Can I do this one in recursive way? Yes, I can. Okay, so public, okay, string static, okay, returning the string, okay, to bin, okay, to binary integer n, okay. So here, if actually n, okay, so if n equals 0, okay, then I'll return empty string. Okay, so here I'm going to try to do different way. So here I would do a string that's an accumulator string. Okay, so right here I'm going to return accumulator string. Okay, and I need this because I don't want to mess up. Okay, I don't want to mess up. I'll explain it later. So here I would have I will return. Okay, I'll return to bin value. Okay, of the n divided by 2, okay, and right here my accumulator, okay, I'll put my digit before it, so it actually n take multiplied by 2 plus the accumulator and then return it, okay. So this one is the same as here. Every time I get a digit and then I get the digit put a digit in front of the previous string. And then I'm going to call the next version until it got 0, and I will actually return it. So this one, I would actually write the basic function, okay? Integer n, okay? And I put the check-in for 0 here, okay? So here I actually put this one here because that's a single 0, okay? That's single 0. Usually, if it's not 0, we'll keep dividing it. So I don't want to add extra 0 into there. So that's why I want it this way, okay? So this one to bin, here it should be n and then empty string to start, okay? This one will also solve the same problem. Okay, it actually in a recursive version. Okay. So this one I show you because the same thing actually is similar to this one, the right 3 digit, because the right 3 digit by here we do not have the right 3 digit. It actually is what is actually to binary. So every digit we actually work on every digit, okay, instead of 3 digit, okay. So you can compare this one to binary version and this one. It messes up because it doesn't actually coordinate the last 3 digit with the remaining digit well. You should print the remaining digit first before printing out the last 3 digit. Okay, that's the mistake it makes. Okay, if no question, we are up to here today. Okay, any question? Any question will be welcome. Anything that you don't know in AP previous exam or some grading issue, I'll help you. Okay. Any question? Okay, so for the people who don't have question, you can be dismissed. Okay. And then whoever has question, you can stay. I will try to help you. Okay. Who has a question, you can go first. Okay. So Damon, go first. Okay.
Oh yeah, for a question. It's not about anything related to AP, but like I have a flight like tomorrow, so like is it fine if I turn in the homework a bit later?
Yeah, okay. We will take it. No problem.
Okay. Thank you. Have a good day.
Okay. Good night.
Thank you. Good night.
Yeah, good night. Good night. Thank you, everybody. Bye-bye.